Let us discuss a theorem. The distance between 2 points r1 comma theta 1 and r2 comma theta 2 is given by under root r1 square plus r2 square minus 2 r1 r2 cos theta 1 minus theta 2. ఈ ఎక్స్ప్రెషన్ ని చూడంగానే you can recollect cosine rule or even resultant of two vectors formula. Let's say y is the initial point and ox is the initial ray. A is point r1 comma theta 1 and b is point r2 comma theta 2. Obviously OB distance will be r2, OA distance will be r1, angle AOX theta 1 and angle BOX theta 2. Now if you observe the triangle AOB, we know side OA, we know side OB, and we also know angle AOB, which is theta 1 minus theta 2. So happily to get AB, we can apply cosine rule in the triangle AOB. AB square will be equal to OA square plus OB square minus 2 OA OB cos of angle AOB. Let us see. Let A r1 theta 1, B r2 theta 2 be polar coordinates of 2 points. Then OA is r1, OB is r2, angle AOX is theta 1, angle BOX is theta 2. From triangle OAB, applying cosine rule, AB square is equal to OA square plus OB square minus 2 OA OB cos angle AOB, which is in turn equal to r1 square plus r2 square minus 2 r1 r2 cos theta 1 minus theta 2. Therefore AB is equal to under root r1 square plus r2 square minus 2 r1 r2 cos theta 1 minus theta 2. This can be used as a distance formula in polar coordinate geometry. Next, let us look at another theorem. This theorem gives us area of the triangle formed by 3 points. Area of the triangle formed by 3 points r1 theta 1, r2 theta 2 and r3 theta 3 is half mod sigma r1 r2 sin theta 1 minus theta 2, which is nothing but half r1 r2 sin theta 1 minus theta 2 plus r2 r3 sin theta 2 minus theta 3 plus r3 r1 sin theta 3 minus theta 1. We have to cyclically expand this summation. Now let us look at the proof of this theorem later. Let us remember this as a formula to calculate area of the triangle. Next theorem, the polar equation of a straight line passing through the points r1 theta 1, r2 theta 2 is sin of theta 2 minus theta 1 by r plus sin of theta minus theta 2 by r1 plus sin of theta 1 minus theta by r2 is equal to 0. So here what you are writing is sin of difference of two angles divided by the radius vector of the third point. Here theta 2 is there, theta 1 is there, so I am writing r. Now we are cyclically rotating to get the other expressions. After theta 2 it is theta, after theta 1 it is theta 2, after r it is r1, after r1 it is r2, after theta it is theta 1 and after theta 2 again it is theta. So this summation is equal to 0. This can be treated as equation of a straight line in polar coordinate geometry. Again let us repeat the theorem. The polar equation of a line passing through the points r1 theta 1, r2 theta 2 is given by sin theta 2 minus theta 1 by r plus sin theta minus theta 2 by r1 plus sin theta 1 minus theta by r2 equal to 0. Here theta and r or r comma theta is any variable point on the line. Let us look at proof for this. Let's say A, B, P are three collinear points. A is r1 comma theta 1 and B is r2 comma theta 2. Distance OB will be r2, OA will be r1 and OP will be r. Angle AOX theta 1, angle BOX theta 2 and angle POX theta. Now because these 3 points are collinear, obviously area of the triangle formed by these 3 points will be 0. So area of the triangle PAB is equal to 0. That is, using the previous theorem, area is given by half mod sigma r1 r2 sin theta 1 minus theta 2, or here in this case r1r sin theta 1 minus theta 1 plus r1 r2 sin theta 1 minus theta 2 plus r2r sin theta 2 minus theta equal to 0. This implies you can take r common from first term and last term, r into r1 sin theta 1 theta minus theta 1 minus r into sin theta minus theta 2 is equal to, throw the middle term the other side, r1 r2 sin theta 2 minus theta 1. Now dividing throughout by r1 r2, the polar equation of the line, that is the locus of the point P, will get converted from r into r1 sin theta minus theta 1 minus r2 sin theta minus theta 2 equal to r1 r2 sin theta 2 minus theta 1 to sin theta 2 minus theta 1 by r plus sin theta minus theta 2 by r1 plus sin theta 1 minus theta by r2 is equal to 0. Again, for this step we have to divide throughout by r1 r2 r. r1 r2 gets cancelled, r remains here. r2 r gets cancelled, r1 remains here. r1 gets cancelled, r2 remains here, and when you segregate on all of them onto the same side, you get this. So polar equation of a line passing through 2 points r1 theta 1 and r2 theta 2 is given by, either you can write it in this form, sin theta 2 minus theta 1 by r plus sin theta minus theta 1 by r theta 2 by r1 plus sin theta 1 minus theta by r2 equal to 0, or you can even write it as r into r1 sin theta minus theta 1 minus r2 sin theta 2 theta minus theta 2 equal to r1 r2 sin theta 2 minus theta 1. Let us see some examples. Taking the origin as the pole and the positive x-axis as initial ray, convert the following polar equations into Cartesian forms. So here in these questions we will be given some polar equations and our target will be to convert them into Cartesian forms. So the first polar equation what we are given is r square cos 2 theta is equal to a square. So we know the conversions, r cos theta will be x and r sin theta will be y. So the given equation we have to convert into terms of r cos theta and r sin theta, and wherever we find r cos theta we have to replace it by x, and wherever we find r sin theta we have to replace it by y. The relations between polar and Cartesian coordinates are x equal to r cos theta and y is equal to r sin theta. So cos 2 theta here in this equation we are writing it as cos square theta minus sin square theta. Grouping them together we have r cos theta whole square minus r sin theta whole square equal to a square is the given equation, and this when we are converting it into Cartesian form, this r cos theta we will replace it by x and r sin theta by y. So the equation will become x square minus y square equal to a square. We know this is a rectangular hyperbola. Next question, theta is equal to tan inverse m. So before starting this question, again conversion from polar to Cartesian form, we have the equations x equal to r cos theta and y equal to r sin theta. So instead of talking in terms of tan inverse of m, it is always convenient to talk in terms of tan theta. So send this tan inverse the other side, m is equal to tan theta. Tan theta we have to again see it in terms of sin and cos. So tan theta we will write it as sin theta by cos theta. So given tan theta equal to m, we have sin theta by cos theta is equal to m. In this, numerator and denominator, when we multiply by r, numerator will be r sin theta, denominator r cos theta. R sin theta we know is y and r cos theta we know is x. So y by x is equal to m, or simply it is y is equal to mx. So tan theta is equal to m represents lines passing through origin and having fixed slope m. Let us see one more question in this format. The given polar equation is r equal to a sin square theta by 2. See, we are comfortable in sin theta and cos thetas. So sin square theta by 2, our target should be in converting it into sin theta or cos theta. We know sin square theta by 2 is 1 minus cos theta by 2. So write sin square theta by 2 as 1 minus cos theta by 2. And in this, let us use the same equations in a slightly different format. Cos theta is x by r, sin theta is y by r, and r square is x square plus y square. In this question, it will be difficult to segregate r cos thetas and r sin thetas separately. So wherever I find cos theta, I will replace it by x by r. Wherever I find sin theta, I will replace it by y by r. And whenever r is left out, r square I will replace it by x square plus y square. So as discussed, the given equation r equal to a sin square theta by 2 can be seen as r equal to a into 1 minus cos theta by 2. Taking 2 the other side and replacing cos theta by x by r, we have 2r is equal to a into 1 minus x by r. So theta is eliminated here. Only left out quantity to be eliminated is r. Before eliminating r, let us segregate this equation. 2r square is equal to ar minus ax. I will take ax the other side, because r, if I have to replace directly, I will have under root x square plus y square. In order to get rid of the roots, I will first take ax the other side and square on both sides. So 2r square plus ax is equal to ar, or r square we know we can replace it by x square plus y square. 2 into x square plus y square plus ax is equal to ar. Now squaring on both sides, 2 into x square plus y square plus ax whole square is a square into r square, which is nothing but a square into x square plus y square. Now you can see ax square here and ax square here getting cancelled. And similarly, simplifying the other things, we have the equation to be 4 into x square plus y square into x square plus y square plus ax is equal to a square y square. Go through the process once again. R equal to a sin square theta by 2. Sin square theta by 2 we are converting it into 1 minus cos theta by 2. Wherever we see cos theta, we are replacing it by x by r. Wherever we see sin theta, we replace by y by r. And r square, we will replace it by x square plus y square. So cos theta is here, we will replace it by x by r. So we have a equation in which r has to be eliminated. 2r square, r square we are writing it as x square plus y square, and here again there is ar. To get rid of ar, I will square on both sides. Ar square, r square, I will replace it again by x square plus y square. Doing all the simplifications, you get the answer to be 4x square plus 4y square into x square plus y square plus ax is equal to a square y square. Let us look at next example. Here we are doing converse of the previous type of questions. We are given the Cartesian equation and we want to convert it into polar form. This is the easiest thing we can do. Wherever we see x, we have to replace it by r cos theta, and wherever we see y, we have to replace it by r sin theta. Let us look at the first question. X square plus y square equal to a square. So x we replace it by r cos theta, y we replace it by r sin theta. We get r square cos square theta plus r square sin square theta equal to a square. You can see r square comes out common, and cos square plus sin square theta is 1. So simply you have r square is equal to a square. So r square equal to a square is equation of a circle. A parabola is given in Cartesian forms. This is your standard parabola, y square equal to 4ax. Y we have to replace it by r sin theta, x by r cos theta. So r sin theta whole square is equal to 4a into r cos theta. R gets cancelled on both sides, sending all trigonometric terms onto one side. We have r equal to 4a into cos theta by sin square theta. 1 cos theta by sin theta you can see it as cot theta, and 1 by sin theta we can see it as cosecant theta. So the same equation can also be written as r equal to 4a into cot theta into cosecant theta. So I think now you should be able to do this. X will be replacing it by r cos theta, y by r sin theta. You have r square cos square theta by a square plus r square sin square theta by b square equal to 1. Taking r square common, answer would be r square into cos square theta by a square plus sin square theta by b square equal to 1. Next example. Taking origin as the pole and the positive x-axis as initial ray, convert the following Cartesian equations into polar forms. Similar to what we have done, a different equation is given. Again we will be replacing x by r cos theta, y by r sin theta. Answer is r square into cos 2 theta is equal to a square. If you remember, we converted this from polar form into Cartesian form in the first question. Here in these questions we have to find distance between the given pair of polar coordinates. 2 points are given, p 2 comma pi by 6 and q 4 comma 2 pi by 3. Distance between 2 points PQ, it is given by under root r1 square plus r2 square minus 2 r1 r2 cos theta 2 minus theta 1. So r1 is known to us 2, r2 is known to us 4, cos theta 1 is pi by 6, theta 2 is 2 pi by 3. Substituting all the numbers and simplifying, we get PQ as 2 root 5. So it's only a substitution question, direct formula based. Distance formula we need to know. PQ is under root r1 square plus r2 square minus 2 r1 r2 cos theta 2 minus theta 1. Substituting all the given numbers, we have the result. Now try these questions on your own. Two pairs of points are given. In first question it is 3 comma pi by 4 and 4 comma 7 pi by 2, 12. And in next question it is a comma pi by 2 and 4a comma pi by 6. Find out the answers first, distance between these 2 points. So the answers are, first question should come out to root 13 units, and in second question you have to get root 13a units. Hope you are correct. Next, given 3 vertices of a triangle, we have to prove that it's an equilateral triangle. Show that the points with polar coordinates 0, 0, 3 pi by 2 and 3 pi by 6 form an equilateral triangle. Let the vertices be some A, B and C. To prove that it is equilateral, 1, we need to talk of the angles, angle between the sides, or alternately we can prove that all the 3 sides are equal in length. So using distance formula, let us find all the lengths. Length AB by distance formula, under root r1 square plus r2 square minus 2 r1 r2 cos theta 2 minus theta 1. r1 is 0, r2 is 3, theta 2 is pi by 2, theta 1 is 0. Substitute the numbers. AB is 3. Similarly, we have to find BC and also CA. Find BC and CA. BC will come out to 3 and CA will also come out to 3. So as AB is equal to BC is equal to CA, we can conclude that it is an equilateral triangle. Next example. Given 3 vertices of a triangle, we have to find area of the triangle. If you recollect the theorem we discussed, area of a triangle, it is given by half mod sigma r1 r2 sin theta 1 minus theta 2. Let the vertices be A, B and C. We know formula for area of the triangle, so we can expand this summation in a cyclic way and get the result. So r1 is A, r2 is 2A, r3 is 3A, theta 1 is 0, theta 2 is theta plus pi by 3 and theta 3 is theta plus 2 pi by 3. Expanding the summation, we have half r1 r2 is a into 2a square sin theta 1 minus theta 2. So it is theta minus, stop. Let us look at the next theorem. The polar equation of a line which is at a distance of p from the pole and whose normal makes an angle alpha with the initial ray is r cos theta minus alpha equal to p. This is similar to normal form of a straight line in Cartesian geometry. I repeat, the polar equation of a line which is at a distance of p from the pole and whose normal makes an angle alpha with the initial line is r cos theta minus alpha equal to p. Let us see the proof. Let O be the pole and OX be the initial line. This is the line which we are talking of. OX is the initial line, and from the pole you are dropping a perpendicular onto the line, and the length ON is P, and this angle the normal is making with initial line is alpha. ON is P, angle NOX is alpha. Now take any variable point P r comma theta on the line. So OP will be R and angle POX theta. Then if you observe the triangle ONP, it is a right angle triangle. Angle NOP will be alpha minus theta, and ON we know it is P and OP we know it is R. And you can also see P is adjacent side to angle NOP and OP is the hypotenuse. So angle NOP, cos of angle NOP is equal to adjacent side ON by hypotenuse OP. That is cos theta minus alpha is equal to P by R, or R cos theta minus alpha is equal to P. Now this we can say is equation of a straight line whose normal is making an angle alpha with the initial line, and it is at a distance of P from the pole. If P is equal to 0, that is distance from the pole is 0, then you get a line which is passing through origin, and its equation will be given by r cos theta minus alpha equal to 0, or theta minus alpha is pi by 2, r can't be 0 for every point on the line, so cos theta minus alpha has to be 0. Theta is equal to alpha plus pi by 2, or theta is pi by 2 plus alpha, or theta is equal to theta 1. Let's say alpha plus pi by 2 is some theta 1, or theta 1 is the angle the line is making with the initial ray. Then theta equal to theta 1 will be equation of a line which is passing through the pole. Take another note. R cos theta minus alpha, as we discussed, equal to P is equation of a line whose normal is at a distance of P from pole and making an angle alpha with initial ray. Expanding this, r cos theta cos alpha plus sin theta sin alpha is equal to P. Segregating the terms r cos theta and r sin theta together, we get x cos alpha plus y sin alpha equal to P, which is nothing but normal form of a straight line in Cartesian form. Just like we discussed in the initial stage, this is similar to normal form of a straight line in Cartesian form. And again, equation of a straight line which is at a distance of p units from the pole and perpendicular to the initial ray. It is given by alpha will be what when it is perpendicular to the initial ray? 0. So r cos theta is equal to p. Another important point to be noted. The equation of a straight line which is at a perpendicular distance of p units from the pole and parallel to initial ray. When the line is parallel to initial ray, perpendicular dropped will be normal to the initial ray. So perpendicular will be making an angle pi by 2. Alpha will be pi by 2. So substituting alpha equal to pi by 2, you get r sin theta is equal to p. You can note down these two equations. This equation of a straight line which is at a distance of p units from the pole and perpendicular to the initial ray is r cos theta equal to p, or we have to take alpha equal to 0 in this case. And equation of a straight line which is at a distance of p units from the pole and parallel to the initial ray, alpha will be pi by 2, or the equation comes out to r sin theta equal to p. Let us see some important points. The polar form of a straight line ax plus by plus c equal to 0. Ax plus by plus c equal to 0, we know it is general form of a line equation in Cartesian system, and similarly in polar form the general equation of a line will be in the form a cos theta plus b sin theta equal to k by r. This is called general form of a line equation in polar form, a cos theta plus b sin theta equal to k by r. So if you observe all the previous line equations whatever we wrote, they fall into one or the other of this form. The polar equation of a line parallel to the general line a cos theta plus b sin theta equal to k by r is a cos theta plus b sin theta equal to k dash by r. You can correlate this with what we studied in Cartesian system. For a line parallel to a given line, the change will only be in the constant term. Here again, if you observe, there is no change in coefficient of cos theta, no change in coefficient of sin theta. The only difference is in terms of k dash. Similarly, the polar equation of a line perpendicular to the line a cos theta plus b sin theta equal to k by r is replace theta with theta plus 90, and there will again be a change in the constant term k. So the equation which is perpendicular to the line a cos theta plus b sin theta equal to k by r, we can write it as a cos theta plus 90 plus b sin theta plus 90 is equal to k dash by r, or this comes out to a sin theta minus b cos theta is equal to k dash by r. You can relate this with what we studied in Cartesian system. To get a line perpendicular to a given line, we used to interchange the coefficient of x and coefficient of y and change the sign in between. Here again, coefficient of cos theta became coefficient of sin theta, and coefficient of sin theta became coefficient of cos theta, and the plus sign in between change it to minus sign, again there being a change in the constant term. To find out k dash, what we need is some additional information about the line. Given a point or given the distance from a fixed point or any other information, we can find the value of k dash. So a review of all these important points again. The general equation of straight line in polar form is a cos theta plus b sin theta equal to k by r. The polar equation of any line perpendicular to a given line a cos theta plus b sin theta equal to k by r is a cos theta plus b sin theta equal to k dash by r, k dash being the only change. The polar equation of a line perpendicular to the line a cos theta plus b sin theta equal to k by r is either replace theta by theta plus 90 or interchange the coefficients of cos theta and sin theta with also a sign change in between. Let us look at some examples. Find polar equation of the line joining the points 5 comma pi by 2 and minus 5 comma pi by 6. Now two points are given, 5 pi by 2 and minus 5 pi by 6. When two points are given, how to express equation of a straight line? We discussed the theorem. Equation of a line passing through the points r1 comma theta 1 and r2 comma theta 2 is given by sin theta minus theta 1 by r2 plus so on equal to 0. Let us use that here. Given the points are a 5 comma pi by 2 and b minus 5 comma pi by 6. Equation of line joining two points r1 theta 1 and r2 theta 2 is, all of you have to know it by heart, sin theta 2 minus theta 1 by r plus sin theta minus theta 2 by r1 plus sin theta 1 minus theta by r2 is equal to 0. Now let us substitute. We all know r1 is this 5, theta 1 is pi by 2, r2 is minus 5, theta 2 is pi by 6, and r theta being the variables corresponding to a variable point on the line. Substituting which we get sine of pi by 6 minus pi by 2 by r plus sine of theta minus pi by 6 by 5 plus sine pi by 2 minus theta by minus 5 is equal to 0. We have to simplify this. Simple trigonometry. So we get sine of theta minus pi by 6 minus cos theta is equal to 5 root 3 by 2r. This will be equation of the straight line in polar form of the line passing through the given two points. Another example. Find polar coordinates of the point of intersection of the lines 2 by r is equal to sin theta plus pi by 3 plus sin theta and 4 by r is equal to 3 sin theta minus root 3 cos theta. So when we have to find point of intersection of the two given lines, we have to find a point r comma theta which satisfies both the equations. Let us see how to do it. These are the given two lines. 2 by r is equal to sin theta plus pi by 3 plus sin theta and 4 by r is equal to 3 sin theta minus root 3 cos theta. Now we have to solve for both r and theta such that r comma theta satisfies equation number 1 as well as equation number 2. So let us solve for theta first. To solve for theta we need to eliminate r. How to eliminate r? We can see 2 by r in equation 1, 4 by r in equation 2. So dividing one by the other, r gets eliminated. So 2 into sin theta plus pi by 3 plus sin theta is equal to 3 sin theta minus root 3 cos theta. Dividing one by the other, 2 and 4, 1, 2 gets cancelled. Cross multiplication, we have this equation. Simply expand sin theta plus pi by 3. Segregate all the terms together. First write the expansion, simplification. We have to write all theta terms together. So you can see sin theta gets cancelled through the equation and you have a simple equation 2 root 3 cos theta is equal to 0, which implies cos theta is 0 or theta is pi by 2. So theta for our point of intersection is pi by 2. Now substituting theta equal to pi by 2 either in equation 1 or equation 2, you will get the value of r. So 2 root 3 cos theta is 0, which gave us theta equal to pi by 2. That pi by 2 we are substituting in equation number 1. We get r equal to 4 by 3. So we can write the point of intersection to be P 4 by 3 comma pi by 2. Is the process clear? From the given two equations we are solving for theta and r such that they satisfy both the equations. First we eliminated r by dividing one equation by the other. We got a simple equation in terms of theta. Usually it will be a linear equation in terms of sin theta and cos theta. Here fortunately we had sin theta to be 0, coefficient of sin theta to be 0. So we got cos theta equal to 0 and theta as pi by 2. If we have sin theta coefficient as well, then we will have a linear equation of form a cos theta plus b sin theta equal to 0, which can be solved by converting either into tan theta by 2 or dividing by root over a square plus b square. And once we get the value of theta, we substitute it either in equation 1 or equation 2 to get the value of r, and that will give us the point of intersection r comma theta. Another example, find polar equation of a straight line which with intercepts a and b on the rays theta equal to 0 and theta equal to pi by 2 respectively. So this is similar to our Cartesian question of writing intercept equation, that is x by a plus y by b is equal to 1, where a is the intercept on x axis. Here we are say it is initial ray or theta equal to 0, and b is the intercept on y axis, and here we are saying theta equal to pi by 2. The line is passing through the points a comma 0 and b comma pi by 2, and simply we substitute these 2 points in our line equation. Theta 1 we have it to be 0, theta 2 to be pi by 2, r1 we have it to be a, r2 to be b. Substituting we get sin pi by 2 by r, sin pi by 2 is 1, sin of theta minus pi by 2 by a plus sin 0 minus theta by b is equal to 0, which is simply 1 by r minus cos theta by a minus sin theta by b is equal to 0, or resegregating 1 by r is equal to cos theta by a plus sin theta by b, and this is equation of a straight line with intercepts a and b on the lines or on the rays theta equal to 0 and theta equal to pi by 2 respectively. Now if you see, take this r the other side, r cos theta we know is x in Cartesian form, r sin theta is y in Cartesian form. So this equation looks like x by a plus y by b is equal to 1. Let us look at another example. Find the polar equation of the lines passing through the point 2 comma pi by 4 and is parallel to 7 by r is equal to 4 cos theta plus 3 sin theta. And second question, perpendicular to the straight line 7 by r is equal to 4 cos theta plus 3 sin theta. Now a line is given. We want equation of a line parallel to this line and passing through the point 2 comma pi by 4. We all know that when a line is perpendicular to a given line, the change will only be in terms of the constant term, not in coefficient of cos theta nor in the coefficient of sin theta. So only number which changes here is 7. So we can assume the line parallel to 7 by r equal to 4 cos theta plus 3 sin theta to be some k by r is equal to 4 cos theta plus 3 sin theta, and to find the value of k we can substitute this point. And in the second question, when we have to find equation of the line perpendicular to the straight line, coefficient of cos theta and coefficient of sin theta will get interchanged, and also there will be a replacement of sin somewhere in the equation, and also there will be a change in the constant term. So equation of any line perpendicular to the straight line 7 by r is equal to 4 cos theta plus 3 sin theta, we can assume it as 3 cos theta minus 4 sin theta is equal to k by r. Okay, let us start solving the question. This is the given line, 4 cos theta plus 3 sin theta equal to 7 by r. Equation of any line parallel to this, we discussed that there will be only change in the constant term. In place of 7 it will be k, and this line is passing through a2 comma for pi by 4. So substituting this point in this line, we get k value, and 4 cos 45 plus 3 sin 45 is equal to k by 2. Thus that gives us k equal to 7 by root 2 into 2, or 7 root 2. Equation of the parallel line is 4 cos theta plus 3 sin theta equal to 7 root 2 by r. Let us find out the perpendicular line equation. We discussed cos theta coefficient and sin theta coefficient get interchanged, and also there will be a sign change in between. So we can write the equation to be 3 cos theta minus 4 sin theta is equal to k dash by r. Or alternately, equation of the line perpendicular to this line. In place of theta, theta gets rotated by another pi by 2 more perpendicular to this line. So in place of theta we can put theta plus pi by 2. This line is passing through a2 comma pi by 4. So substituting a2 comma pi by 4 in the equation, we get the value of k dash. K dash is coming out to minus root 2. So equation of the line perpendicular to this line would be 4 sin theta minus 3 cos theta is equal to root 2 by r. Next example. There are two straight roads intersecting at an angle of 60 degrees. A car is moving away from the crossing. There are two straight roads OA and OP intersecting at an angle of 60 degrees. A car is moving away from the crossing at a rate of 25 kmph at 10 am. At 10 am there is a car at O and it is moving away from O at a speed of 25 km per hour. Another car is 50 km away from O on the other road. So it is at the point A. A is 52 km away from O and is moving in the direction towards the crossing. It is moving towards O at a rate of 47 kmph at 10 am. Then find the distance between the cars at 11 am. So if you understand the question, one car is at O and is moving away from O, and another car is at A and is moving towards O on this line. Now initial stage, it is both the cars are at 10 am. One is 52 kilometers away from origin and another is at the origin. The car which is at the origin is moving along the initial ray, and the car which is at 52 kilometers away is moving along the line which is at 60 degrees frequency, and the car is moving towards O. Now we have to observe the distance between the cars at 11 am. First let us see where the cars will be at 11 am. The car is moving, first car is moving along the initial ray and with a speed of 25 kmph, and between 10 am to 11 am we know it is 1 hour passed. So in 1 hour it will travel 25 kilometers. So after 1 hour at 11 am the car will be at point P, which is 25 comma 0. 25 is the distance to 25 kilometers and 0 because it is along the initial ray. And if you see the other car, initially it is at distance of 52 kilometers from origin. In 1 hour time, that is between 10 am to 11 am, it would have moved by 47 kilometers. It is traveling with a speed of 47 kilometers per hour. So in 1 hour time it would have moved 47 kilometers. So from 52 kilometers, if this 47 is removed, we are left with 5 kilometers. So the car, second car at 11 am would be at a point Q, which is 5 kilometers from the initial point, and inclined at an angle of 60 degrees with the initial raise. So Q coordinates would be 5, 60. Let us see the working. Let P and Q be the positions of the car at 10 am and 0 be the pole. P is first car, Q is second car at 11 am. Let O be the intersection of the roads. Let A be the position of the second car at 10 am. OA is given to be 52 kilometers. Let O be the position of first car at 10 am. It's at initial point. Velocity of the car is 25 km per hour. That's the first car, and that of the second car is 47 km per hour. OP is 25. In 1 hour time it would have travelled 25 kilometers. OQ is 5 kilometers. OA is given to be 52. A to Q it travelled 47 kilometers, so the leftover distance is 5 kilometers. Angle POQ is 60 degrees. Now Q coordinates are known, P coordinates are known. We can now apply distance formula to get PQ square. PQ square is given by R1 square plus R2 square minus 2 R1 R2 cos angle POQ. R1 is 5, R2 is 25, cos angle POQ is cos 60. Substituting, we have PQ square to be 525 or PQ to be 5 root 21 kilometers.